Hey everyone, and welcome to a deep dive into AI and software engineering.
Sounds exciting.
It is. Today we're going to be looking at this new benchmark called SWE-Lancer.
Right.
And I think you're particularly interested in this one because it's really trying to figure out if AI can actually do real-world software engineering tasks. You know, the kinds of things that freelancers handle every day.
Yeah, and even potentially, could AI actually replace those freelance
Okay,
engineers?
so like no pressure then, right?
Yeah.
But seriously, tell me a little bit about SWE-Lancer. What makes it so special?
So SWE-Lancer, what makes it so unique is that it's built on a data set of over 1,400 real freelance software engineering tasks.
Wow.
These were taken directly from Upwork.
Wait, Upwork, like the
Blueprint
actual...
form, yep.
So we're not talking about some theoretical coding challenges here. This is like AI going head-to-head with real freelancers on real projects.
Exactly. And the combined payout for all of these tasks is $1 million.
Whoa.
So it's not just passing tests in a lab, it's about producing work that has real economic value.
Yeah, $1 million.
Mm-hmm.
I'm starting to see why this is such a big deal.
Right.
So what kinds of tasks are we talking about? Is it all about fixing bugs, or is there more to it?
So SWE-Lancer actually includes two main types of tasks.
Okay.
The first are individual contributor, or IC tasks.
Okay.
And these are your kind of typical coding assignments, bug fixes, implementing features, that kind of thing.
Got it.
But then there's a second category called SWE management tasks.
Management tasks. Wait, so the AI is not just writing code, but like making decisions about the best way to solve a problem.
Exactly. So these management tasks assess the AI's ability to kind of act as a tech lead, choosing the best solution from a set of proposed solutions.
Okay.
It's really about, can they think strategically about a project, not just, write the code?
Okay. That's pretty mind-blowing.
Yeah.
So it's not just about coding skills, but it's about problem-solving and decision-making too.
Yeah.
This is, I'm guessing, pretty different from other coding benchmarks out there.
You're absolutely right. So, there have been other benchmarks out there.
Right.
But SWE-Lancer really stands out in a few key ways.
Okay.
So first, this real-world payout aspect, this is a game changer.
Yeah.
It raises the stakes, and it forces the AI to produce work that's not just technically correct, but like economically valuable.
Makes sense.
The second thing is that this inclusion of management tasks, this is also unique.
Right.
It reflects the reality of software development where good management is essential for success.
Yeah.
And then third, the tasks themselves are just more complex.
Oh, right.
We're talking about advanced full-stack engineering tasks that require a really deep understanding of how different parts of a software system interact.
So SWE-Lancer's throwing some pretty tough challenges at these AIs.
It is.
I'm getting a little nervous for them.
Right.
But you mentioned one more thing that I wanted to touch on before we dive into how well they actually perform.
Yeah.
And that was about the grading process using end-to-end tests.
Right.
Can you explain that a little bit more?
Sure. So end-to-end testing is a way of evaluating software by simulating how a real user would interact with it.
Okay.
So it's like running through a whole recipe from start to finish instead of just checking if the ingredients are fresh.
Right.
And these tests are much harder to kind of game than just simple unit tests, which only look at isolated pieces of code.
Right.
And because they were created by professional software engineers, it means we get a much more comprehensive and realistic evaluation of the AI's work.
So it's like the AI is being judged by a panel of expert chefs rather than just a cooking show host.
Right.
Pretty high stakes.
High stakes.
And to make things even more interesting, these tasks, they cover a wide range of software engineering areas, right?
Absolutely, yeah. So we see tasks related to application logic, UI UX development, and of course the ever-present bug fixes.
Yeah, can't forget about those.
Right. It's a really diverse mix that puts these AIs through their paces.
Okay, so we've got this super realistic, benchmark challenging tasks, rigorous grading system, and now I'm dying to know, how did the AI do? Did it manage to take home that $1 million prize?
Well, the results are definitely interesting and perhaps a little bit reassuring for human software engineers out there.
Who do too?
So the top-performing model was Claude 3.5 Sonnet.
Okay.
And achieved a pass at one accuracy of 26.2% on the IC tasks and 44.9% on the management tasks.
Pass at one accuracy. I think you might have lost me there. Could you break that down a bit?
You're right. Sorry. Got a bit technical there. So pass at one accuracy just means the percentage of times the AI produced a correct solution on the first try without any additional times revisions.
Okay, so 26.2% on the coding tasks and 44.9% on the management tasks.
Right.
That means the AI still got the majority of the answers wrong, right?
Yeah.
So it looks like human freelancers can breathe a sigh of relief for now.
Exactly. While those numbers are certainly promising, it's clear that AI still has a long way to go before it can fully replace human software engineers.
Right.
Over 70% of the solutions generated were incorrect.
Yeah.
And in the real world, that kind of error rate could have significant consequences.
Yeah, you definitely don't want an AI accidentally
Right.
crashing your entire app or
Okay.
sending out $1 million invoice to the wrong person.
Right.
But now I'm really curious, how does the AI even approach these tasks? Does it just randomly change lines of code and hope for the best?
Not quite.
Okay.
It's actually fascinating to observe how these AIs tackle these problems.
Really?
It's almost like watching a detective solve a case.
Intriguing. Can you elaborate on that?
Of course. So the AI starts by carefully scanning the files, looking for any clues related to the task at hand.
Okay.
It'll use keywords from the task description to guide its search, and it tries to understand how different parts of the code base connect and interact with each other.
So it's not just blindly changing things. It's actually trying to understand the problem and the code base before making any moves.
Right. It's not simply a brute force approach. There's a level of reasoning and analysis happening.
Interesting.
And what's remarkable is how quickly these AIs can narrow down, the potential problem areas within the code. They can often pinpoint the buggy code, much faster than a human could.
Wow, that's seriously impressive.
Yeah.
But I guess the real question is, can it actually fix the bug once it's found it?
Right.
Finding the problem is one thing, solving it is a whole other ballgame.
You've hit the nail on the head, and this is where things start to get even more interesting. And we see the AI's current limitations begin to show.
Okay, this is where it gets really interesting. Tell me more.
Well, remember how we talked about those end-to-end tests being much more rigorous?
Yes.
That's where the AI often stumbles.
So it might be able to fix the obvious problem, but then break something else in the process.
Sometimes, yes, it might miss those subtle interactions within the code or, fail to grasp the broader implications of its changes.
So it's like playing whack-a-mole with bugs.
Right.
Fix one and then another one pops up somewhere else. I imagine that can get pretty frustrating.
It can, and it highlights the need for AI systems that can reason more holistically about code. They need to understand not just the syntax, but also the semantics, the intent behind the code.
Right, like understanding the developer's thought process.
Yeah.
Why did they write the code this way? What were they trying to achieve?
Exactly, and that level of understanding is something that current AI models are still struggling with.
So it's not just about teaching AI to code, it's about teaching it to think like a coder.
Right.
That sounds like quite the challenge.
It is, but it's a challenge worth tackling.
Yeah.
And SWE-Lancer is providing valuable insights into, how we can move forward.
Well, this is already a lot to process.
Yeah.
I need a moment to wrap my head around all of this.
Yeah.
AI, playing detective, fixing bugs, managing projects. The future is getting closer than I thought.
It definitely is, but before we get too carried away, let's dig a little deeper into some specific examples of how the AI performs on these tasks. Would you be interested in hearing about a few cases that really stood out to the researchers?
Absolutely, I'm all ears.
Great. I think you'll find this next part particularly fascinating. So there were a few instances where the AI's performance was particularly noteworthy.
Okay.
One example involved a task where the AI had to fix a bug that was preventing a validation error message from appearing.
The classic missing error message.
Right.
I've spent countless hours tracking those down myself.
Oh, yeah.
It sounds like a deceptively simple problem, but it can often be quite tricky to fix.
You're absolutely right. And in this case, the AI not only managed to pinpoint the buggy code, but it also figured out how to fix it in a way that addressed all potential edge cases, something that even experienced human engineers might have overlooked.
Wow, so it wasn't just a superficial fix.
Right.
The AI really seemed to understand the underlying logic of the validation process and implemented a comprehensive solution.
Yeah.
That's pretty impressive.
It really was. It was
Yeah.
almost like the AI was thinking ahead,
Yeah.
anticipating potential problems and proactively addressing them. These moments really give you a glimpse of the potential of AI in software development, especially when it comes to tasks that require a really deep understanding of the code base.
So it's not just about blindly following instructions or applying pre-programmed rules.
Right.
It seems like the AI is developing a more intuitive understanding of how code works and how to solve complex problems.
That's a great observation, and it's this ability to kind of learn and adapt that sets AI apart from traditional software tools.
Right.
However, it's important to remember that, AI still has its limitations.
Of course.
While it might excel in certain areas like bug detection and code optimization, There are other aspects of software engineering where it still struggles.
Right. We talked about how the AI can sometimes miss those subtle interactions in the code or, fail to grasp the bigger picture.
Yeah.
Are there any other limitations that stood out to you?
One key limitation is that SWE-Lancer.
Okay.
While groundbreaking is still based on a single codebase, Expensify.
Okay.
And while Expensify is a fairly complex and well-structured project,
Uh,
it's still just one slice of the vast world of software development.
so it's like judging a chef based on their ability to cook one specific dish.
Right.
They might be amazing at making that one dish,
Exactly.
but we don't really know how they would fare with other cuisines or techniques.
Exactly. To truly assess the capabilities of AI in software engineering,
Yeah.
we need to see how it performs on a much wider range of tasks and code bases.
Right.
Different programming languages, different architectures, different domains. All of these factors can influence how well the AI performs.
That makes a lot of sense. And I imagine there are other limitations as well, right?
Oh, absolutely.
Real-world software development is rarely as clean and straightforward as these benchmark tasks.
Right. The tasks in SWE-Lancer are designed to be relatively self-contained.
Okay.
They don't fully capture the complexity of real-world software projects,
Yeah.
where engineers often have to collaborate, communicate, and navigate ambiguous requirements.
Right.
It's like testing someone's swimming skills in a pool,
Huh.
but not in the open ocean. They might be a strong swimmer in a controlled environment, but struggle with the unpredictable currents and waves of the real world.
That's a great analogy.
Right.
So while SWE-Lancer is an important step forward,
Yeah.
it's not the be-all and end-all of AI evaluation and software engineering.
It's not.
We need to keep pushing the boundaries, developing even more robust benchmarks that can truly capture the nuances and complexities of this field.
I couldn't agree more.
Yeah.
And that leads us to some very interesting questions about the future of AI in software engineering.
Okay, so we've talked about all the impressive things that AI can do with code, and we've also acknowledged that there's still some, hurdles to overcome.
Yeah.
So what does all this mean for the future of software engineering? What kind of impact can we really expect from AI in this field?
That's the million-dollar question, isn't it?
It really is.
It's a topic that sparks a lot of, debate and speculation.
Yeah.
Some people believe that AI will eventually automate software development entirely, leading to widespread job displacement for human programmers.
Right.
Others are more optimistic, envisioning a future where AI kind of augments human capabilities,
Okay.
allowing us to build even more complex and innovative software systems.
So those are two very different scenarios.
They are.
Where do you fall on that spectrum? Are you team robot overlords or team human AI dream team?
I tend to lean towards the more optimistic view.
Okay.
I believe that AI has the potential to revolutionize software development, but not necessarily in the way that some people fear.
Okay.
Instead of replacing human programmers, I think AI will become an essential tool that empowers us to work more efficiently and creatively.
I like that perspective.
Yeah.
It's not about AI versus humans,
Right.
but rather AI and humans working together to achieve greater things.
Exactly.
So in this human AI dream team scenario, what role do you see AI playing in the future of software development?
I think we'll see AI taking on a lot of the, repetitive and time-consuming tasks that currently bog down human developers.
Okay, like what kinds of things?
Things like code generation, bug detection testing, and even some aspects of project management.
Oh, wow.
These could be significantly automated with the help of AI.
That sounds pretty appealing.
Yeah.
Imagine a world where you can just describe what you want your software to do, and the AI generates the code for you.
Right.
That would free up so much time and energy for human developers to focus on the more, creative and strategic aspects of software development.
Exactly. Humans could focus on things like designing, elegant user interfaces or solving complex architectural challenges and really ensuring that the software meets the needs of its users.
Yeah.
We could finally move beyond the mundane tasks and embrace the true art of software craftsmanship.
It sounds like a win-win for everyone involved.
It does.
But even in this optimistic scenario, there will likely be, challenges and adjustments that need to be made.
Right.
What are some of the potential roadblocks we might encounter along the way?
Well, I think one of the biggest challenges will be ensuring that, these AI systems are reliable and trustworthy.
Oh, okay. We need to be confident that the code generated by AI is correct, secure, and meets, the required standards.
Yeah.
This means developing robust testing and validation methods specifically for AI-generated code.
Right. It's one thing for an AI to write some code, but it's another thing entirely for that code to actually work as intended and be free of vulnerabilities.
Exactly.
We don't want to create a whole new set of problems while trying to solve existing ones.
Right. And another challenge will be addressing the potential ethical concerns that arise from using AI in software development.
Okay.
For example, how do we ensure that AI systems are not biased or discriminatory in the code they generate?
Right.
How do we maintain human oversight and control over these systems as they become more powerful and autonomous?
Those are important questions that need to be carefully considered.
Yeah.
It seems like the future of AI and software engineering is not just about, technological advancements, but also about having those open and honest conversations about the ethical implications of these technologies. Absolutely. It's a complex and multifaceted issue that requires collaboration and dialogue between developers, researchers, policymakers, and, society as a whole.
Well, this has been an incredibly insightful deep dive into the world of AI and software engineering.
It has.
We've learned about SWE-Lancer, this groundbreaking benchmark that is really pushing the boundaries of what AI can do with code.
Yeah.
We've explored the potential benefits and challenges of integrating AI into the software development process. And we've even touched upon, the ethical considerations that need to be addressed as these technologies continue to evolve.
It's been a pleasure sharing my insights with you, and I hope this deep dive has given you a better understanding of, the current state of AI and software engineering and the exciting possibilities that lie ahead.
It definitely has. And to everyone listening out there, we hope this sparked your curiosity and given you some food for thought.
Yeah.
As AI continues to evolve, it will undoubtedly have a profound impact on the way we build software. So stay informed, stay engaged, and who knows, maybe you'll be the one to shape the future of this really exciting field. Thanks for joining us on the deep dive. We'll catch you next time for another fascinating exploration.